Hello, let's continue our Sudoku adventure with Reward by Crusader175. So, we have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have Nabner lines in the grid. This is Renban backwards, so they're kind of backwards from Renban, but do pay attention to their rules. So, yellow lines in the grid are Nabner lines. If a digit appears on a line, such as a 2, then the digits consecutive with it do not appear anywhere on the line. So I can't put a 1 or a 3 anywhere on this line if there's a 2 on it. So once we put a 2 on it, that excludes both 1 and 3. You also can't repeat digits on the Nabner line. So let's say I have a 2 here. I can't put a 1, 2, or 3 anywhere on the line other than where that 2 already is. So hopefully that makes sense. In addition to that, we do have these black crop key dots and white crop key dots. So the black dots separate digits with a 1 to 2 ratio. So that another way to think about that is one of the digits is always exactly double the other. Doesn't matter what order they're in, but if this was a 2, this could be a 1 because 2 is double 1, or it could be a 4 because 4 is double 2. White dots separate consecutive digits. So if this was a 2, this could be a 1 or a 3. They just have to be consecutive. Not all the dots are given, meaning this could be 2, 4. There's no black dot. That's fine. It could be 2, 3. There's no white dot. That's fine. This is allowed. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay. Let's think about where we want to get started here. These two digits are consecutive, and then there's a Nabner. So let's think about a length 3 Nabner, because all of these are length 3 Nabners. If I were to put a 2 on a Nabner line, then I can no longer put 1 or 3 on the line. So I'm down to 4, 5, 6 just naturally. And if you think about it, if I were to try to put a 5 somewhere, that would exclude both the 4 and the 6. So that's not allowed. So actually, if there's a 2 on the line, it must be 2, 4, 6. Coming from the other direction, if there's a 5 on the line, 4, 5, 6 are gone, 1, 2, 3 is left, but you can't actually do 2. And so if there's a 5 on the line, it is 1, 3, 5. So those are the forcing digits, the 2 and the 5. Now you could do something like 1, 4, 6. That would be fine. So those aren't the only two options. It's just those are forcing digits. 2 and 5 are forcing digits. So now that's the biggest thing I know about Nabner. See if we can do anything with that. One of these will have a 2 or a 5 on them at least, right? Because we can only put, like this box has a 2 and a 5 in it, and this is the only cell that's not on a 3 cell Nabner. So one of these will be a forced Nabner. I'm not sure which one. I don't think it can be this one. Imagine this was the 2, 4, 6 Nabner. If it had a 2 on it, 2, 4, 6. Well, I'm thinking about the 2, 4, 6 one. If this was a 2, 4, 6 Nabner, what are we putting here? We can't do 1, 2. We can't do 2, 4, and we can't do 3, 6, and those are the only pairs that can go on a black dot. Because a much easier way to put this is a black dot always has at least one even number on it, because we're literally doubling one of the numbers, and that makes it even. And so this uses up all the even numbers, so we are not able to make this a 2, 4, 6. So this has an odd digit on it, at least one. Can it? I'm trying to think. There seems to be more limitation here that I'm not quite getting. But I'm wondering if we can, like, if we can prove this is just a 1, 3, 5-er. Let's ask this question: can we omit both the 3 and 6 from this line? So 1, 2, not 3, 4, 5, not 6. Is this allowed? And I would say, no, it's not, because the one, if you think about the group 1, 2 and the group 4, 5, one of those groups will have both of its members in it. This is one way to think about it. There's probably a million other ways to think about it. Some you may consider easier, but think about that. So I can have one from 1, 2 and one from 4, 5, but not the other one because they're consecutive. So I can't fill all 3 of these with just 1, 2, 4, 5. So this line will have a 3 or a 6 on it at least. That's true of all of our Nabner lines. And so this can't be a 3, 6 pair. So this is from 1, 2, 4, and it definitely contains a 2. And that further proves that this does not have The 2 is down here. This does not have a 2 on it. So can this be 1-2 pair? This would be 3, 4, 5, 6. And we have the same exact problem. We could group the 3, 4 and the 5, 6 together. One of them would have both digits on it. So this is not 1, 2. This is 2, 4. And what we're left over here with, and I am going to write it out. So let's put a 4 down here. But we're gonna be left with 1, 3, 5, and 6. So if you think about it, I can't have both 5 and 6 on this Nabner line. So only one of those 5, 6s will be there, which means the other 5, 6s right here. Oops, the other 5, 6s right here. So this will be 1 and 3, along with one of 5 or 6, both of which are viable. So we can't distinguish that right now. And then this is the other 5, 6 that this line doesn't choose. Okay, now if we know if it's a 5, then this ends up being 5 with a 1, 3 pair. It does things, it does a lot of things, but I don't think it's a problem. I don't think it's a problem. Okay. Yeah. This being 2, 4 really limits things. But let's see. If this was a 2, we'd end up with 2, 4, 6, as we talked about. Let's see, these are consecutive digits. Is that interesting? Well, we know it's not. We know there's no 6 on here. Because if there was a 6 on here, it would be 5, 6 pair, and that breaks this cell. So these are from 1 through 5, but I'm wondering... Another way we can kind of think about these Nabner lines in a more general sense is they're also kind of like a how do I put it? Like you're gonna have only one of 1, 2, only one of 3, 4, and only one of 5, 6. So we can kind of group those in that way. So that's why we can't omit like a 5 or a 6. We can't omit both 5, 6. We can't omit both 3, 4. We can't omit both 1, 2. Right? So the other 5, 6 ends up on this line somewhere. And I guess it could be here, technically. So that means that these are from 1, 2, 3, 4, because the other 5, 6 is on this line. And now this can't be 1, 2. This can't be a 1, because if this was 1, 2, just as I said, this has a 1 or a 2 on it, so that's not going to work. So this is actually from 2, 3, 4, and it must contain a 3. Okay, and if it must contain a 3, this can't have a 5 on it. Because remember, 5 forced 5, 3, 1. Right, let's go over that again. If there's a 5 on here, then the remaining digits are from 1, 2, 3, but we can't actually include the 2 because it's going to be consecutive with the 1 or the 3. So it does have a 3 on it. So because there's a 3 in this white dot, there's a 3 on this white dot to be 2, 3, or 3, 4. That means there cannot be a 5 on here. So there's no 5 on any of these cells. So this is the 5. And 5 does force this to be a 1, 3 pair. I did say that would be limiting, and that's exactly what happened. So this doesn't have a 5 on it. It does have the 6 on it. It's 1, 3, 6. This is a 1, 3, 6 as well. So this can't be 6, right? We need a 6 on one of these two. So 5 and 6 do end up down here somewhere, along with the other 1, 3. This is a 2, 3, 4 triple, right? So if you think about it, yeah, okay. So then this has to be the 4, right? Because okay, let's just go over this. This can be 1, can't be 2, 3, 4, can't be 5, 6. So this is a 1, 6 pair. So this can't be a 2 because there is a 1 on it. So, but the way I actually thought about it is, remember we need at least one of 3, 4 on this line. Well, this uses up the 3, and so this has to have a 4 on it. So that's where the 4 goes. And this is not a 4. So now this is a 2. So the 2 is hiding here. I said either the 2 or 5 could, and the 2 did end up there. This 1, 6 pair does make this 3 and 1. Makes this the 1, 6, and 3. Nice, all resolved. So now we know that this is just a 3, 5, 6 triple. Okay. This is really good progress. This is neat so far. I'm enjoying the flow here. We know this isn't 3, 6, and we know it doesn't contain a 1. So this has to be 2, 4. So that has to be 4, 2 like that, because of this 2 here. And so now this is our 5. So there's a 4 on here. So these can be from, these can't have a 1 on them. They could have a 2 on them, but only here. can't have 3, 4, or 5 because of the 4. And so the other digit's a 6, I guess. Right. Okay, so I guess the point is we need 1 from 1, 2. And neither of these can be 1, and only this one can be 2. So this is our 1 from 1, 2. This is our 1 from 3, 4, and then we need a 5, 6. But 5 is too close to 4, so this has to be 6. All right. And putting 2 on here does make this a 2, 4, 6, as I talked about earlier. Lots of ways to see that. So the 2 makes this a 3 because they're consecutive. This 6 does resolve the 1 and 6. Okay. I'm going to fill these pairs down here for the columns. We need 4, 6 here. We need 1, 5 here. And then this, we need 4, 5 here. Interesting. 4, 5. So again, if this is 5, this is a 1, 3 pair. So this would be 3, 1. Let's get these pairs as well. We need a 1, 4. And here we need a 3, 5. Okay, so we got to think about this line then. It needs 1 from 1, 2. These can't be 1, 2. So this is our 1, 2 digit. And then 1 from 3, 4. And we know 5. Okay, but 5, there's no 6 on here, right? 6 C's here and here. And this isn't a 6 because we needed a 1, 2. So that has to be the 1, 2. And so that means there is a 5 on here, which means there is not a 4 on here. So this has to be the 5 and 3. Now that there's a 3 on there, there can't be a 2. So that's a 1. Or 5 does force 1, 3, as I talked about. So that's 1 and 5. That's 4. That's 5, 4, and 1. We get our 6 and 5. We get our 2 and 4. 6, 4. And then this digit's a 3, giving us the 2, 3. And then we need 2 and 6. They go in that order. And we're done. This was a neat puzzle. Thanks, Crusader. Really interesting ways to think about how Nabner lines, 3-cell Nabner lines work in a 6x6. Pretty neat. Hope you enjoyed it as well. If you did, then why not leave a like, subscribe, and a kind comment below.